So you saw how all of this started. It started basically 1940. It took a long time until this stuff get better than humans. It took even longer to beat the world best AlphaGo player, and in this video I want to show you the future, because Nvidia has big plans. We had a TED talk with Jim Fan. He's basically one of the key guys at Nvidia. He tells us first a little story, we will skip that he was basically in school and couldn't listen to the teacher because there was right now this moment in 2016 where this algo was better in Go than Lee Sedol. So AlphaGo was born and the vision of Nvidia, the vision of Jim Fan started, and they have made incredible stuff, and I want to show you this right now completely from the source. So this is the TED talk, we need to see this.
The AI has just won 3 out of 5 games and became the first ever to beat a human champion at a game of Go. The glory moment when AI agents finally entered the mainstream. But when the excitement fades, I realized that as mighty as AlphaGo was, it could only do one thing and one thing alone. It isn't able to play any other games, like Super Mario or Minecraft. And it certainly cannot do a dirty laundry or cook a nice dinner for you tonight. But what we truly want are AI agents as versatile as Wall-E, as diverse as all the robot body forms or embodiments in Star Wars. This is a practitioner's guide towards generally capable AI agents. Most of the ongoing research efforts can be laid out nicely across 3 axes: the number of skills an agent can do, the body forms or embodiments it can control, and the realities it can master. AlphaGo is somewhere here, but the upper right corner is where we need to go. So let's take it one axis at a time. Earlier this year, I led the Voyager project, which is an agent that scales up massively on the number of skills. And there's no game better than Minecraft for the infinite creative things it supports. And Minecraft is so insanely popular because it's open-ended. It does not have a fixed storyline for you to follow, and you can do whatever your heart desires in the game. And when we set Voyager free in Minecraft, we see that it's able to play the game for hours on end without any human intervention. The video here shows snippets from a single episode of Voyager, where it just keeps going. It can explore the terrains, mine all kinds of materials, fight monsters, craft hundreds of recipes, and unlock an ever-expanding tree of skills. So what's the magic? The core insight is coding as action. First, we convert the 3D world into a textual representation using a Minecraft JavaScript API made by the enthusiastic community. Voyager invokes GPT-4 to write code snippets in JavaScript that become executable skills in the game. Yet, just like human engineers, Voyager makes mistakes. It isn't always able to get a program correct on the first try, so we add a self-reflection mechanism for it to improve. There are 3 sources of feedback for the self-reflection: the JavaScript code execution error, the agent state, like health and hunger, and the world state, like terrains and enemies nearby. So Voyager takes an action, observes the consequences of its action on the world and on itself, reflects on how it can possibly do better, try out some new action plans, and rinse and repeat. And once the skill becomes mature, Voyager saves it to a skill library as a persistent memory. You can think of the skill library as a code repository written entirely by a language model. And in this way, Voyager is able to bootstrap its own capabilities recursively as it explores and experiments in Minecraft. So let's work through an example together. Voyager finds itself hungry. It needs to get food as soon as possible. It senses 4 entities nearby: a cat, a villager, a pig, and some wheat seeds. Voyager starts an inner monologue. Do I kill the cat or villager for food? Horrible idea. How about the wheat seed? I can grow a farm out of the seeds, but that's gonna take a long time. So sorry, piggy, You are the chosen one. One question still remains. How does Voyager keep exploring indefinitely? We only give it a high-level directive. That is to obtain as many unique items as possible. And Voyager implements a curriculum to find progressively harder and more novel challenges to solve, all by itself. And putting all these together, Voyager is able to not only master, but also discover new skills along the way. And we did not pre-program any of this. It's all Voyager's idea. And this, what you see here, is what we call lifelong learning, where an agent is forever curious and forever pursuing new adventures. Compared to AlphaGo, Voyager scales up massively on a number of things it can do, but still controls only one body in Minecraft. So the question is, can we have an algorithm that works across many different bodies? Enters Metamorph. It is an initiative I co-developed at Stanford. We created a foundation model that can control not just one, but thousands of robots with very different arm and leg configurations. Metamorph is able to handle extremely varied kinematic characteristics from different robot bodies. And this is the intuition on how we create a metamorph. First, we design a special vocabulary to describe the body parts so that every robot body is basically a sentence written in the language of this vocabulary. And then we just apply a transformer to it, much like ChatGPT. But instead of writing out text, Metamorph writes out motor controls. We show that Metamorph is able to control thousands of robots to go upstairs, cross difficult terrains, and avoid obstacles. Extrapolating into the future, if we can greatly expand this robot vocabulary, I envision Metamorph 2.0 will be able to generalize to robot hands, humanoids, dogs, drones, and even beyond. Compared to Voyager, Metamorph takes a big stride towards multi-body control. And now, let's take everything one level further and transfer the skills and embodiments across realities. Enters Isaac Sim, Nvidia's simulation effort. The biggest strength of Isaac Sim is to accelerate physics simulation to 1,000x faster than real time. For example, this character here learns some impressive martial arts by going through 10 years of intense training in only 3 days of simulation time. So it's very much like the virtual sparring dojo in the movie Matrix. And this car racing scene is where simulation has crossed the uncanny valley. Thanks to hardware-accelerated ray tracing, we're able to render extremely complex scenes with breathtaking levels of details. And this photorealism you see here will help us train computer vision models that will become the eyes of every AI agent. And what's more, Isaac Sim can procedurally generate worlds with infinite variations so that no two look the same. So here's an interesting idea. If an agent is able to master 10,000 simulations, then it may very well just generalize to our real physical world, which is simply the 10,001st reality, and let that sink in. As we progress through this map, we will eventually get to the upper right corner, which is a single agent that generalizes across all 3 axes. And that is the foundation agent. I believe training foundation agent will be very similar to ChatGPT. All language tasks can be expressed as text in and text out, be it writing poetry, translating English to Spanish, or coding Python, it's all the same. And ChatGPT simply scales this up massively across lots and lots of data. It's the same principle. The foundation agent takes as input an embodiment prompt and a task prompt and output actions. And we train it by simply scaling it up massively across lots and lots of realities. I believe in a future where everything that moves will eventually be autonomous. And one day, we will realize that all the AI agents across Wall-E, Star Wars, Ready Player One, no matter if they are in the physical or virtual spaces, will all just be different prompts to the same foundation agent. And that, my friends, will be the next grand challenge in our quest for AI.
And this was the supercut of this TED Talk. I think this is completely awesome. Jim Fan did a great job to explaining all of this, and let's just summarize this with a few words, because I think we need to put this also in our other words to really recognize what's going on. So it all started with AlphaGo. This was the key concept. Then Nvidia, they basically built an AI agent and they called it Voyager. Voyager can play Minecraft completely autonomically. They simply told him, hey, the goal is to learn a lot of skills. And basically every time he does something that is right, he rewards himself with code. And also this code, this is written by ChatGPT. So these machines are also really good in rewarding themselves. So not just only reinforcement learning from human feedback, but like reinforcement learning from robot feedback, or however you want to call this. This is completely mind-blowing. And the problem was, of course, that this Voyager agent can only play Minecraft. But we need to play different games. We need to play the reality, if possible. And they try to make this happen, because they have like Isaac Sim and Metamorph. And with these two tools they can do completely amazing things. So with Metamorph they basically can control a lot of different bodies in a lot of different environments. They can train everybody in every single environment in a simulation. And as soon as they have trained into this simulation, like over and over and over again, the 10,001st simulation can be the real world. This is completely mind-boggling. And of course they have more problems they need to see. But also this seems to be doable, because they can render extremely complex and realistic looking frames, and they can train these bots on all of this. And the training will be extremely fast thanks to Isaac Sim. Isaac Sim is something like a time machine. So they can train all of this in no time in different environments, and they can train different bodies. And they also try to make these bots see. And as soon as all of this merges together, we have this foundation agent. And this foundation agent is able to cook, is able to clean your house, is able to control a lot of different bodies in a lot of different environments. And this is basically the future. And Jim Fan believes in a future where every single robot is completely autonomous. Let me know what you think. I am not sure about timelines. Even Jim Fan is not sure about timelines. I am also not like really sure if this ever happens, but it seems that Jim Fan is really confident, and maybe he has a little bit more insights than us. All these guys, they seem to be really confident that all of this will happen. And if we look at the progress of technology, also to me, this seems really reasonable. So we live in completely mind-boggling, exciting times. What do you think?